Hi, welcome to the stream. We'll talk about physics constraint for setting up this chain. It's not going to be a perfect simulation of the chain. There are a lot of things to consider, like friction or influencing each node on each other. So basically we'll be doing physics simulation with what we have in this version, which is one physics constraint which affect only one bond and its children, or yeah, you will see it in action in a moment. So I will also be doing this one from scratch, and as well I would like to make another version where we have 2 points anchored, so you see the limitations and maybe you have a better idea how to do it, because right now I'm still in the experimentation process. I just wanted to share that process with you. Great. So this is what we have. You can see we have a little bit bouncing up and down, which we can turn off, and we have a rotation delay for physics. And if I rotate it, we see the bottom part is hanging, that we will have the gravity for it affecting. It's looking cool. It's pretty much enough for the animation. And this is the beauty of this new version. I mean, it's still in the beta, or alpha. It's not available public yet. But the idea is to have minimum tools to create whatever we mostly need in practical process of animation. And we don't have like multiple bonds, constraints like springs, etc., and collision. We just have one constraint that affects only one bond. One constraint affects only one bond. So let's see. We have this chain. Each image is separated, you can see, and they are already placed in the bond, their bonds. Here's it. So the first thing we do here is select all the bonds, create new, and transform constraints. Physics constraints, sorry. We can see one constraint is created for each bond. I will select all of them and save under number 1 using Control 1. And you can see we have simulate enabled. That means it's already will simulate the moment we enable any of those properties we see above. Translate X, translate Y, rotation, shear X, scale X. So right now I will do the rotation. It is already something that you can see. This might be useful in some cases where you have a snake slithering through a muddy surface. But not now. So let's see what we can fix. I'm selecting all of them, and we have inertia. I will try to explain a little bit physics for those who missed our previous streams. So I'm working with one bond. Let's create the physics, and I will reduce the strength. This is the one that brings the bond to unconstrained pose. So when I move it, let me work on rotation. When I move it, you can see the bond is pointing to the previous position. So this is inertia, and higher it is, more it will point. and it's not going back to like no new position. It's not going back because we have strength 0. The only reason it will go back like hanging again if we enable strength, and you can see a lower value make it easy slower to come to that pose, and higher value will just make it faster. The other way we can fight inertia is the wind or gravity. Those are the forces, a similar way as the strength. So strength is fighting inertia to bring it to new pose, the one that would normally be if we move the bone, considering its rotation and its position new. So if I move this bone here, this is the new position. This is called unconstrained position. If I turn on simulation and again move it here, you can see it still goes to this pose because we have inertia, and it's avoiding being here. And the reason it can be here is when we enable strength. So strength will bring, after some time, it will bring to unconstrained pose. If instead of the strength we move the gravity, the similar effect might be because gravity is forcing down, and eventually it will be bring it to equilibrium and pointing down. But if our bone is something like this and we have inertia, and rotation, so if I move it and add a strength, you can see it will bring to that horizontal pose. But if instead of strength I make the gravity, it will bring the vertically down. So gravity always pulls it down, while strength is always brings it to the pose where it should be without constraint. So this is the difference. If bone initially points down, gravity and strength pretty much looks the same. So this is with gravity, you can see that it is hanging, and this is with a little bit wind, you can see it's hanging. So initial pose is not considered here because we have strength 0. The only way we can consider initial pose is to give the value. So if I raise it, you will see that it's trying to go to the initial pose, but it won't because it will need to fight gravity and wind as well. So let's try. I'm giving a higher value so you can see the wind, gravity and strength all together are forces. The strength fights to be here horizontally, winds tries to be to the right, and gravity pulls to the down. This we have in between pose. So all that said, here I'm coming back to here, and let's now try to fix. If I go inertia this and reduce the damping so we see like some oscillation, and reduce the mass, give higher strength maybe. So this is obviously not like chain, not behaving like chain. Maybe we have higher lower damping. Let me see. So the reason it is not realistic because we are actually bringing back to original pose, and instead we can simulate it by just replacing strength with the gravity, because we really need that chain to hang. So instead of that, now if I move it, you will see it's just moving and it's not bringing back to original pose. It's just like a trail, static trail. And I will select all of them and add the gravity. Now it will fall down. Reducing damping. maybe less inertia, less mass. So this is pretty much something you can play with. But with just rotation and gravity, a little bit inertia, we can simulate this. So you know that there are much more than this rotation. So our chain should also be able to move like this. And whenever it hits the other node, it should consider collision. So there are a lot of things that is not being considered here. And with this physics constraint, we clearly can't consider all of them. One thing we can do is make a little bit springy, because some chains, even though they are made from solid material, they can have a little bit springy, stretchy. Just for the sake of that, I will create another set. I'm going to use different settings for that, so I don't need the same physics constraint, because here all of them, all properties will go under the same settings. I need the scale to have different settings. So for that, I will create another set and save it under 3 and use scale X. This is also not perfect. It's not going to be perfect. I will show you what does the scale for one bone, and then we can set it here. So this is the scale. Again, as with rotation, when you move it up, the scale, if we have inertia, I will reduce the strength right now. If we have inertia, it stretches just to be in the previous pose. And only scale works. So if I also turn on rotation, you will see that it's pointing to the original pose. While if we increase the strength, it will go back to normal. So this is what scale actually does. Answering to questions, I really don't know. I have not tested, but developers said that there wouldn't be any performance issue. It's a little bit lighter than actually other constraints. So I don't think we should worry about it. Okay, so this out of the way. I will create constraints. And try to enable only scale. It's going to be subtle. I really don't need too much here. And still, I will only need, I think, the gravity. Maybe with some strength. I need that strength to fight the gravity, otherwise it will constantly flow down. See, increasing the strength will bring actually it back. At some point, they should actually find equilibrium, which is not something we look, because each affects its children. That's why at the bottom we see very stretched one. So I think we can't go with this. Maybe we can try to disable the scale for inheriting. This way each of them will affect on their own. So you can see a chain is stretching and going back. I will try to find some value here. Okay, a little bit stretching. This is also something you can add. Another thing, we can add moving them, like not the scale, but also moving them. This will give another setting. I'm just showing you what you can do, but clearly I might go with just rotation because it depends what this do in the animation, but I'm just complicating it so you just see what can be done. Let's create another set of physics. Save it. Here I will use only translation. Why? Gravity, and it will start to go down, increasing strength, reducing the gravity. Maybe we don't need gravity with this setup. Yeah. It's already like at the edge, so with gravity it already breaks the setup. So apart from stretching each bone, we also have movement. It's a little bit springy. Yeah, but this is you can do. So I will go and delete all the constraints to keep only rotation. So with this setup, we only have one constraint for each of them. And we can clearly use it without any springing effect. It still can work for us. Now, the other issue I would like to tell is to make a path. Let me check something. I will need a little bit of strength. So when I rotate, I actually see it curves here. It looks a little bit laggy, but it's not a problem. I think they will fix it easily. Mute my phone. So when I rotate it, the strength value is actually make it to rotate. Otherwise, it will always try to be at the bottom. So we have strength and gravity together working to have this nice curvature. You can also go ahead and edit the values one by one for each of them and maybe give a little bit less dampiness here. So the bottom section is a little bit more, has a little bit more oscillation. because this one is clearly, this joint has very little mass compared to the other ones. So it's really up to you. But I will remove that because I'm going to attach the anchor to the bottom. This I did not try this, so I will be doing it now. If I fail, sorry for that. But I really wanted to struggle with you watching, so you also see all the solutions. Let's see. Let's see. I'm looking for some slow left and right, but I don't know if I can actually achieve that, because if I reduce the dumpiness, which will allow that, this makes things to oscillate very fast. Like this is the one who allows us to actually oscillate, but it does it very crazily. So I don't have any information about the release of this version. Sorry for that. I think to have more control over this weight here, we can create a path, and I will just try. So this will be our path, and all these bones will go there. I'll constrain them. Now I will remove all the constraints here, or just turn off simulation. And make a length here. So I will move this bone inside the main container here and bind the weights, the mesh to those bones. Where is it? Here and here. Maybe I still need to put this bone here because they will detach at some point. But let me simulate, so later I do it later. Okay, now I need to create one constraint just for this. And this is where I have more control. I will use rotation and translate. And add gravity. Move back maybe. Okay, so I can see how path is working. Maybe we can reset constraints and see if spine can help us. So you can see it's actually detaching from it. I will need to create another bone on the tip of this. And put this there. Just trying some crazy stuff. I want that rotation from this big bone. So maybe I can take it using transform constraints. Now let's adjust the physics. I need more rotation offset actually, but I can't do that with this setup because right now rotation, translate, they use the same. I love the translate difference, but I need different rotation. So maybe I can turn it off here and create another one and use rotation. Maybe bigger rotation, so inertia should be higher. I see it actually rotates, but I don't see why it's not applying. Yeah. Now it rotates a little bit more. I'll try to give more delay to the anchor. And let's try to see if we can make the path work. Let's see, rotation, too much strength and more gravity. Maybe even less strength. I'm looking at the bone actually because the image has an offset, and I will check it. This constraint should actually copy this one. Let's see why it's not copying. Yeah, now it's copying. So we have our anchor mostly hanging. And the reason why we have this so straight is because we will also need to reduce the strength from the translation anchor constraint. Reducing that, giving higher gravity. Yeah, something like this, I guess. I will need to disable this. We don't need those. Okay, I accidentally removed the simulation, I guess. Somehow. Back to the track. So it means that if I disable simulation for one physics, it also disables for all the other ones. Or yeah, how can this be true? I don't understand this. So for physics to work for this bone, somehow it forces two others to also work. I don't want to say it as a fact because I might be just incorrect. I need to double check this. But pretty much if I disable simulation for this, I go back here and simulation is turned off here. If I turn it on here, I go back and I see it turned on here. So let's for now turn it on. Maybe all the structure can't work if the children nodes are not there. Something I need to ask developers. Anyway, I don't want to bore you more. I will go ahead and create this setup. It's again not going to be perfect, but we need to try and test. So we have this. I will delete them and this. Okay, now we are back to normal setup and removing this path. I already have this path, just a path, no constraints. So let's create constraints. And what's happening here? I think I missed one bone. And where is it? Okay, it was hidden. Great. And the path is small, so let's make it bigger. Something like this. The next thing I see there, we have an offset of the chain. We don't like that. So we have an option in the chain and constraints, or path constraints, to change the tangent to chain. So right now you can see that bones are tangent to the path. Changing to a chain will make sure they are connected to each other. And changing to a chain scale will force them to be scaled, the bones, if it's needed. If there is a very short turn curvature, yeah, it will be scaled. We don't need that. We want the original scale of the chain. And that's the reason why we can't fix both edges right now, because we don't have that ability. As far as I know, it's something like an IK for constraint, path constraints, something like that. So even if I move this, you can see the other end will come with that, because we have fixed length for the bones and it can't be scaled. There is no other way. I can't like fix this point here, and whenever I drag it, it just stops. So for that, some IK setup should be there to stop us moving. But it's I tried with that, but it's not a cool idea. So think of a bone here, which has an IK constraint, one bone, which has compress, stretch locked, and compress unlocked. So We can move it. We can move it this way, but we can't actually move out. So this way we will always have that radius, but it's not going to work in this scenario, because we really want not just fix this curvature, but also because right now what would happen in real, it would go a little bit down and shrinking this curvature. So the real physics is not just fixing it here like instantly. So I tried with that. I will try again, but right now let's create a basic setup. So moving it here, moving this here. And let's select the path, find it here and here. Okay, so this is that. This is the path. And what we need to do is just create rotation physics constraint, reduce the damping, add the gravity. I want it to be hanging. Reduce the strength and try it. So I can see path is already being affected. Just move it down in the hierarchy. Maybe more damping, less damping, more inertia. So this is very slight effect that we can achieve. But as you can see, up and down movement won't be affected. As I said, if I try to move it up, we will see this going down, up and down, which we don't want. And even with, if I move it too much here, you will see this one is not looking like attached. I'm gonna try to also add a scale. I want to see what that will do. So scale X, and the moment I increase the gravity, it will start to stretch. Let's leave it right now. I will bring it back by just scaling down. I don't know if this is a normal way to do it. You can see now scale also works. And damping, not wind, a little bit mass, dumping. Okay, you can see we have a little bit up and down, but that comes with the price because we have here going up and down. I don't know how to do that without stretching. I mean, I can come here and turn on chain scale, which will fix this, but we will, yeah, we need to change to spacing to proportional and give 100%. Should be, yeah. So this way we can make sure that both edges are fixed, but that will make the chain to change its scale of the nodes and become a rope or rubber. We don't need that. So yeah, as I was saying, we can create an IK constraint here for this bone and just try to limit compressing, stretching. So I will only turn on compress and it will prevent it to stretching too much. So I will come back here to change it back to length and change back to chain. So now this bone can compress but can't stretch. Let's put it here. So you can see it compresses, but then all of a sudden stops because we have, and even it even starts going up at some point. I will just try to reduce the oscillation increase. So this is not something I would like to see, not realistic physics. And yeah, let me know how it looks for you so far. I will go quickly and tell you all the limitations we have, or something, because you might expect to see a great physics here, but being realistic and practical is better here. So first of all, one thing that the bone length is really matters. Longer bone simulates a little bit heavy with exactly the same physics. So I will select both of them, create physics, rotation. Let's remove them. You can see the small bone seems lighter. So if I set the bone length to 0, there won't be any rotation. And this also works for the scale. So without bone's length, only the translation works, this X and Y. Otherwise, it's just there. The length of the bone needs for calculations. The next thing, as you already saw, we can constrain one bone to multiple physics constraint. Right now, properties are not separated, the mixed value, so we have only one mixed value here. Maybe in the future we will have sliders here. That would be great because we will use one constraint for different properties. But right now we will need to copy, make another constraint. Another limitation that seems that can come with this constraint, but it's actually not there, the springing. So imagine we have a grid of bones and you want to drag this and the other also affect that, like a mesh. But I did not find any way to simulate that, because the only way you can do is to create put all of them here and then create constraints and give them some delay or bone length difference. That way you will see some randomness, but clearly this bone will not affect this bone or the otherwise. Only parent affects the children bone. That's the relationship I see right now. Again, I'm not official representation of developers team. I'm just lucky to receive the closed version, the alpha version, to play and maybe showcase to you, so you also give your insights and maybe concerns. Anyway, so whatever I'm saying here, don't take it as a full true fact, because tomorrow I can say it the other way. I'm still in the experimentation phase. The other thing that I really miss, and I spoke to them and they said maybe they can add it later. So imagine we have bone that rotates here. But you can see that it pretty much rotates in world space. So all physics work in world space. Even if I put this bone inside another bone, and scale this bone just to mimic that frame of reference, skewed frame of reference, this bone will still be simulating in the world space. So there is no actually local space. Nie tu informacji Phil show. There is no information about the release of this version. Okay, so there is no local option. I was assuming maybe we can have local button here as we have with translates, constraints, transform constraints. The other thing we don't have is, I mean, it's not that they promised and they didn't give. is gravity or wind being global variable. So right now, if I set any gravity here, if we have working with real characters and we have clothes hanging, you would assume that all that clothes should be assigned to the same gravity, but you will need to go and manually assign them. So if one day you want to change that gravity for all of them, you will need still to select all of them and change that. So I was assuming we might have that global variables, and we could assign that gravity or wind to them. So all sand uses one wind. This is another limitation. That we don't have right now. One more thing that people are confusing is that the wind is going to be great. Hey, let's simulate the wind. So wind, what we have now is just a force that applies left to right, like horizontal force, a similar way as the strength, but strength is forcing the bone to go to a constraint pose. So if your bone is rotated up and move to the left, it will force it to go there and still look up. While gravity or wind always force them to point that direction you actually set, because if you set a positive higher value for gravity, your bone will try to point down. Negative gravity will point up, and if translate also enables simulation property, it will also reach up to fight the strength force. If strength is 0, it will forever like move the way you actually set with wind and gravity. So wind is not something that is going to animate your character. It's just a force that points that way. To animate the wind, to simulate the wind, you will have to manually set the values up and down and play with them. So there is no actually, which I'm going to ask them if it is something realistic to have in this version. So imagine you would have a drop down box here, and there would be presets, strong wind, slow wind, like, or anything. And if you set them, this property is actually fluctuates, and the value is actually changing to show that even here with just wind being there, you will see that bone moving without moving that bone. So the wind will affect consistently on that bone, and that would also apply on the character and in the animation without even you animating them. But right now you will have to animate that wind. Even if they introduce the sliders here, that keys, which we don't have right now, just the buttons, you will still need to go up and down, change the direction here and there. So you will be simulating the wind. It's not something like we have in other programs where you enable the wind, set some parameters, and wind works. So this is another limitation we have right now. What else? Yeah, I think this is for now something I have. I'm very happy with what we have, and even though I said we don't have the mesh, springs, or collision, all those are outside from this version scope. I'm really happy with what we have, because in practice, we really don't use that very much. I mean, of course, we use that collision. We might use some ball for falling, but in the animation, we mostly, what we really need is just that secondary movements, that follow through movements of the clothes or some hanging stuff, and that's what's most important and takes too much time. I mean, that ball falling on the ground, if they introduce that, you will need to create collision boxes, etc., and make sure that works, and it would take so much time from us to actually set it up. I'm not against of that, obviously. And what I'm saying is just I'm happy that we have this simple start with this version. Maybe later we can add more and more. Yeah, what we really need, they actually introduce it, and this is pretty much enough personally for me. So that said, I think I will be finishing now, and thank you for watching. If you have any question, apart from when the release will be out, because I really don't know, I have no information, and it's not up to me. We don't have questions, and yeah, sorry for this unfinished works or streams. I just sometimes find a little bit time to experiment, and I really want you to see how this experimentation is going, because I would like to see it if other people do something that I can't do at the moment. Hey, yeah, that's actually sad if you are using 3.8, and a lot of people are using that when they are working in full-time jobs. Mostly in that company, they use that fixed version. But if you are freelancer, once in a while you receive projects that are 4.1, and so freelancing is a little bit better because yeah, versions change much better, faster. Yeah, the Medusa head, of course. Tentacles are super easy to animate with this. Okay, see you in the next stream or video. Thank you very much.